Artworkium. Welcome back to Inventive Legacies, patents that shaped our lives. This is the series where we really get into the details behind the designs. We focus specifically on patents you can find in the Artworkium Patent Prints online store. And we actually decided to create this whole series partly as a way to say thank you for those of you who've supported us, maybe bought one of our digital prints. Think of this as an extra resource, a little bonus for your loyalty. Today, we're looking at something pretty fascinating. It tries to blend like science class with a board game. The patent title, it's Chess Set Construction. And you'll find this one in our Toys and Games section.
Yeah, and this one, honestly, looking at the drawings really helps you get it. So we've put a link to the actual patent print we're talking about right there in the description for this deep dive. You should check it out. Because what we're digging into today, it's less your standard chess set and more like, well, an educational machine. It uses physics to teach rules and even abstract ideas like value.
Okay, educational machine. I like that. Let's unpack it.
Yeah.
So we're looking at U.S. patent number 5,662,326. Filed back in August 96.
Okay.
And the patent was granted September 2nd, 1997.
Right.
The inventor was Nagib Gebran out of Forest Hills, New York. And he assigned it to a company called Educational Chess Enterprises, also in Forest Hills.
And, the problem Gebran was tackling, it's something anyone who's ever taught chess knows. Beginners, they break the rules, not like on purpose, but because the rules can be really abstract, right? So the big idea here, the mission, was to make chess easier to grasp, especially for younger players, maybe elementary age. And the key was integrating physics and math. So the board itself kind of helps enforce the rule.
Wow, okay. Make the board the enforcer. That's pretty smart. So if we're talking beginner frustrations, what's rule number one that trips people up? My guess, it's got to be the piece that moves sideways, but not really.
Huh. You mean diagonally? That's it, the bishop. The patent points out that the bishop's move diagonal only and stuck on its starting square color is a constant source of confusion. Kids are always trying to put a light squared bishop on a dark square or, the other way around. It means they made an illegal move somewhere back there.
Right. It happens all the time. So how do you use magnets to, chain the bishop to its color?
Okay, so you basically build a polarized battlefield, the whole board, magnetized, but with alternating polarity.
Alternating. How?
Well, the patent lays it out. All the light squares have their north polarity facing up towards where the pieces sit. And then, you guessed it, all the dark squares have their south polarity facing up.
Okay, so you've got this grid, north, south,
Yeah.
like a magnetic checkerboard. Now, what about the pieces?
Exactly. Now, you magnetize the pieces to react to that grid. You want attraction for legal moves, repulsion for illegal ones. So take the bishop that starts on a light square. You put a magnet in its base with the south pole facing down.
South pole down.
So when that bishop lands on a light square, which has north facing up, what happens?
North and south. They attract. It sticks.
Right. It settles nicely. But now, what if the student tries to move that same bishop onto a dark square?
Dark squares are south facing up. Bishop has south facing down. South and south. They repel.
Bingo. The board literally pushes the piece away. You feel the rule.
That's enforcement you can feel. Oh, okay, but wait. That stops it landing on the wrong color? Does it help make sure the move itself was diagonal?
Yeah.
Or stop someone just sliding it sideways across squares of the same color?
Good question. And that's where the sort of continuous interaction comes in. Think about moving that bishop. It has to cross over multiple squares, right? Let's say someone tries to slide it just sideways, maybe across 3 light squares.
Right.
To do that, the path between those light squares inevitably has to get close to the dark squares in the next row or column.
Which have the repelling south polarity for this bishop.
Correct. So the moment that piece even drifts slightly towards an adjacent dark square column, that repulsion kicks in. It resists. The path of least resistance, the easy path, becomes the straight diagonal, moving from one attracting light square to the next.
So it doesn't just correct the landing, it sort of guides the movement vector using physics. That's subtle.
It's teaching the correct path with scientific precision, yeah.
All right, this is getting really interesting now. But the patent didn't stop with just the bishop, did it? What other classic beginner mistakes does it tackle with magnets?
Well, it addresses the other big one, the ultimate no-no.
Don't tell me. Putting the kings next to each other.
Exactly. Placing kings on adjacent squares, instant illegal move, game over usually, if not caught. The patent offers this really clever optional feature for this. It uses repulsion again, but differently. This time, the magnets are in the kings themselves, and they're set up not to mess with the board's polarity grid we just talked about.
Okay, how do you manage that? Repulsion between pieces, but no interference with the board's magnets.
They use vertical rod magnets inside the kings, and here's the key. Both kings have the magnet oriented the same way vertically. Let's say North Pole facing up in both.
I see where this is going.
Right. If a player tries to put those kings on squares right next to each other, the two North Poles get close.
And they'll push each other apart. A physical, nope, can't do that.
That's it. A little physical nudge, a warning. Forbidden move.
A self-correcting security system for the kings.
Yeah, nice. And I remember seeing in the drawings, it mentions these king magnets have to be placed high up in the piece.
Yes, exactly. To avoid what you called magnetic chaos, they need to be positioned in the upper part, above the main magnetic field interaction happening between the bishop bases and the board squares. That's some thoughtful engineering, managing multiple magnetic fields.
It really is. It shows they thought about the practicalities. And while the bishop gets the main magnetic treatment, the patent does float the idea of using the same principle for the knight.
Oh, the knight, the L-shaped jump, that confuses everyone. How could magnets possibly guide that specific move?
Well, the concept described is pretty clever. It actually reinforces a strategic idea. Knights are better in the center. They sketch out a setup where, around the knight's starting square, the board polarity is specially arranged. The 8 squares a knight can legally jump to, they'd have the opposite polarity to the knight's base magnet, attracting it.
Okay, so pull it towards the legal landing spots.
Right. But the squares immediately around it, the ones it can't move to in that first step of the L.
They repel it.
Precisely. The system would physically map out the knight's possible moves. So imagine a knight in the center. The player would physically feel those 8 pull points radiating out, more options, but then move that same knight to the corner of the board, say square A1, how many legal moves from there?
Only 2.
Exactly. And the magnetic setup would reflect that. Only 2 attraction points would be felt.
Wow. That's a really physical way to teach strategy. You always tell beginners knights are better in the center, but this shows them why. The available energy or potential for movement literally shrinks near the edge.
Yeah, it turns an abstract strategic concept into something you can almost physically feel.
Okay, mind slightly blown by the magnetic stuff. That covers the first big feature, using physics, magnetism, to enforce movement rules. Now let's switch gears. You mentioned a second major feature, equally clever, using mass to teach value and algebra.
That's right. This is where Gebran basically turns the chess set into a hands-on math lesson. The pieces themselves are physically weighted, and they're weighted according to their generally accepted exchange value in chess.
Exchange value, like how many pawns a knight is worth.
Sort of, yeah. It takes that abstract idea, which is hard for kids to really get, and makes it tangible. You can weigh them.
Okay, so what's the standard value system in chess, and how do they translate that into actual physical weight?
Well, the pawn is usually the baseline, value of 1.
Okay, pawn, 1 unit.
So the patent uses a ratio for the weights. It's roughly 9-5 to 3-1. Pawn is 1 unit of weight. The knight and the bishop, they each weigh 3 units.
So if you put a knight on one side of a scale and a bishop on the other.
They balance perfectly. Physical proof that 3 equals 3, and that they're considered equal value in a trade.
Clever. What about the others?
The rook weighs 5 units, and the queen, the most powerful, weighs 9 units. Exactly 9 times the weight of a single pawn.
9 times, okay. And the king, since you can't trade the king, it has infinite value in the game.
Correct. So the king has no exchange value for these calculations, but the patent is specific. The king piece itself must weigh slightly more than the queen.
One more.
Just to convey its importance, its royalty, through sheer mass alone. But it doesn't get used in the balancing exercises, so it doesn't mess up the math.
Right, got it. So the learning part comes when you use these weighted pieces with like a balanced scale. The patent drawings show scales.
Exactly. That's where the algebra connection happens.
Yeah.
The scale provides the physical proof. So a student makes an even trade in the game, maybe swapping their knight for the opponent's bishop. They take those captured pieces, put them on the scale.
Knight 3 units on one side, bishop 3 units on the other, and it balances. They see the equality.
Yep. But the real magic, I think, is with the unequal trades, where you learn about substitution. Let's say you capture a rook. That's 5 units.
Okay, rook 5 on one side of the scale. How do you balance that?
Well, you'd need pieces that add up to 5 on the other side. Maybe a bishop. That's 3 units.
Need 2 more.
Right. So add 2 pawns, each is 1 unit.
So bishop 3 plus pawn 1 equals 5.
And the scale balances. It physically demonstrates the equation. 5 equals 3 plus 1 plus 1, or 5 equals 3 plus 2.
You are literally seeing algebra happen with chess pieces. You're swapping abstract numbers for real weights. That idea that a rook is worth, say, a bishop and 2 pawns isn't just a rule someone told you. It's something you can physically prove right there.
It gives kids this really visceral, hands-on understanding of value, proportion, substitution, fundamental math concepts, all hidden inside a game of chess. It's like geometry with the magnets, algebra with the weights. Pretty amazing, really.
It really is. We've covered a lot of ingenuity packed into just this one patent. Makes you wonder how much learning potential is just kind of hidden in everyday toys. So we've got to ask you, our listener, what part of this educational chess set stood out the most to you? What did you find most surprising?
Was it the whole idea of the board using magnets to, like, physically stop you from making illegal bishop moves?
Oh, yeah.
That attraction and repulsion teaching the rules?
Or maybe it was that concept for the knight, using magnetism to show why it's stronger in the center, mapping his potential moves physically.
Or perhaps it was the weighted pieces. The fact that you could teach algebra, literally balancing a rook against a bishop and 2 pawns on a scale.
Let us know. Share your thoughts on social media. And hey, follow Artworkium for more deep dives into these inventive legacies. Maybe leave us a review where you're listening. It helps.
So just to recap, Nagib Gebran's really unique chess set construction, patent US 5,662,326. It had this cool dual approach. First, the magnetic system, enforcing rules for bishops, warning about adjacent kings, physics as the teacher, and second, the proportional weighting system, using mass and a balance scale to teach algebraic concepts like exchange value. Math made physical.
We really hope you enjoyed this look at how even an ancient game like chess can be updated with, science and math principles to teach some pretty complex stuff. Thanks again for your loyalty and for exploring these inventive legacies with us. Before we go, here's something to chew on. Thinking about education. Which concept do you think is more broadly applicable? Is it the magnetic system that kind of dictates movement and forces rules through physical force? Or is it the weighting system that teaches abstract value using tangible mass? It's like the difference between using force to guide action versus using mass to demonstrate value. Something to think about next time you play chess, magnetic or not.
Join us next time for another deep dive into the world of iconic patents. Goodbye for now.